let's take a look at part B of this. So we need to explain why there must be at least one time in which the derivative equals 2. So somewhere on this interval from 2 to 10, there needs to be one time the derivative equals 2. So when you run into a problem like this that they're saying that the derivative needs to equal something at least one time on an interval, this is talking about the mean value theorem. You always ask me, how do I know this? It's because honestly, the same questions, there's only like so many different types of questions they're going to ask on here. The same question is always seeming to pop up. So what is the mean value theorem? Well, the mean value theorem, it states that, if h is continuous, on the interval from A to B, continuous and differentiable actually, but we already know this differentiable, so I should have added that in there. So if h is continuous and differentiable, on the interval from A to B, then there exists a value C, and C needs to, where C is between A and B, such that, and this is the main part that you guys need to remember, such that f prime of, or we're using h this time, so such that h prime of C equals h of B minus h of A over B minus A. So I'm not jumping right into your answer yet. This is just a bunch of fancy talk going through what the mean value theorem is. So really, when you see a question like this, you don't need to write all of this out on the AP test. You just need to kind of remember that, hey, it's the mean value theorem, and remember this formula right here. This is the main part of the mean value theorem. Now notice the requirements. H needs to be continuous and differentiable. Now, remember how I was saying this is just a bunch of fancy talk earlier, that h is a twice differentiable function? Hey, guess what? We're covered. That h is differentiable. And remember, differentiability implies continuity. Why is that? So if something is differentiable, it's continuous. Why? Because it cannot be differentiable if it's not continuous, because discontinuities cause it to be not differentiable. So by the fact that it says it's differentiable, it meets those first two conditions. Is that important? Yes, because you can't use the mean value theorem otherwise, because all we have here is a table, so we really can't assume that this formula is going to work on this table without knowing that it's differentiable, which means that it's also continuous. So now we need to go ahead and see. We need to see, does it ever equal? So we're going to need to actually answer the question now. So does h prime of t equal 2? We need to find an interval. So an interval where the slope is 2. So I'm going to start, it's going with 2 to 10. Why don't we just start with that? So h of 10 minus h of 2 over 10 minus 2 is going to be 15 minus 1.5 over 10 minus 2, which is going to be 13.5 over 8. That's not equal to 2. So that doesn't work. So we need to find an interval here. I'm going to go ahead and try some other things. I'm looking right here. 6 minus 2 is 4. Over 5 minus 3 is 2. Guess what? 4 over 2, that would work. So let's try another one. So h of 5 minus h of 3 over 5 minus 3. Well, h of 5 is 6 minus 2 over 5 minus 3. Equals 4 over 2, and guess what? That equals 2. So bingo, that works. So that checks off. So what does this mean? So bringing this to it, is there somewhere in this interval in which between 2 and 10 our derivative equals 2? Well, yeah, on the interval from 3 to 5. So on the interval I just realized that we are talking about time here, so I shouldn't be using x, I should be using t on the interval from 3 to 5. H prime of c, or there exists a value c is what we should say, such that h prime of c equals 2. And you would explain because it has to do with this right here. And this is enough explanation. This part right here is enough explanation. And you probably should bring up that it's continuous and differentiable in this explanation. So you should say, because h is continuous and differentiable on the interval from 3 to 5, there exists a value c such that h prime of c equals 2. So that should be added in there. And I'll just go ahead and add that in there, might as well. So let me see, I'm going to say therefore since h is differentiable, it is also continuous on the interval I forgot my L. Man, I'm just making a mess of this, aren't I? There we go. So therefore, and I'm going to bring this down just to emphasize this needs to be part of your answer as well. So this is kind of the main part. So you run through that and you say, therefore, since h is differentiable, it is also continuous on the interval 3 to 5. There exists a value c such that h prime of c equals 2. Let's see, it's still a little bit rough. So therefore, since h is differentiable, it is also continuous on the interval. We'll put where there. That kind of smooths it out. Too bad you can't take this assessment on an iPad and do all these little edits while you're doing it. So there you go. That's using the mean value theorem. So once again, this is the main part. You're just finding an interval where the derivative equals the slope or the average rate of change. This is just all fancy talk, technicalities. It's 1 point just for just finding this part, the basic part, and then the rest of this is 1 point. So, if this confuses you too much, just give it your best shot at just trying to think through it. If not, just get the basics down that somewhere the derivative needs to equal the average rate of change.